Hi, grade nines. So in a follow-up to the lesson 2 that we just completed, I wanted to do an activity together. It's about linear relations and specifically talking about the importance of slope and y-intercept. We are going to talk about the equation of a line, and that's going to be coming up in lesson 4. Lesson 3 is actually a bit of an easy one, so it's a nice in between lesson there. But I first want to just discuss what slope and y-intercept is. I want to make sure that you're really, really clear on this idea before we move any further. So in order to do this, like I said, this would be an activity we would do in class. And ideally, we'd be doing it together for maybe 2 or 3 days. But we're a little bit rushed, as you can probably see. So we're going to try to do this as best we can online. So I'm hoping you have this handout out, and maybe you printed it out, or maybe you're just have a PDF version. You can actually write on it. I'm not sure, but I would definitely recommend writing this out so you can do the table of values here with me. So what we're going to do in this question is we're going to first fill out the table of values so that we can graph this line here. So to find our y values, I'm maybe going to do it here on the side so you can see the work. All I'm going to do is I'm going to sub in my x coordinates that, again, I decided to pick because they were easy. No particular reason for picking -2 all the way up to 2 other than just they were easy numbers. So generally speaking, like I said, I would recommend choosing -2, -1, 0, 1, and 2, just because those are small, easy numbers to work with, and it gives you enough variation. You do want to have at least 1 or 2 negative numbers in there, okay? So what we're going to do is we're gonna take our independent variable and we're going to sub it into our dependent variable. We're going to take our independent variable, sub it into our equation. That's what I meant to say, so that we can find our dependent variable. So we're going to take 3 and we're going to multiply it by -2 plus 2. So all I'm doing is I am taking my independent variable in this case, which is -2, and I'm subbing it into this into this equation right here. Now I'm actually going to simply delete this for now because I'm just realizing at the moment that's probably going to be easier for me to annotate this handout as I go along, and then I can upload it pretty easily. So I'm just going to erase this. I apologize for that. Just want to get this going here. So we have our marker here, perfect. So as I mentioned already, I'm going to take my -2 and I'm going to sub it into my equation. So this is going to be 3 times -2 plus 2, and this is going to give me -6 plus 2, and -6 plus 2 is -4. So that means my y coordinate here is -4. I'm going to follow along the same idea here for the next one. I'm going to take y is equal to 3 times -1 plus 2, and 3 times -1 is -3, and then -3 plus 2, what does that give me? That gives me -1. So that means my y coordinate here is -1. So all I'm doing here is I'm taking my x coordinates and I'm subbing them into my equation over here, okay? And again, I'll just replace the x coordinate here with the x values that I've chosen. And again, I just picked them because out of convenience, right? So continue on here, I have y is equal to 3 times 0 plus 2. 3 times 0 is 0, plus 2 is 2. Next one, I have y is equal to 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5. And I continue on here, I have y is equal to 3 times 2 plus 2. And 3 times 2 is 6, plus 2, which gives me 8. And I'm almost done here. I have y is equal to 3 times 3 plus 2, and this is going to get easier now. They're positive numbers. 3 times 3 is 9, and then I add 2. That ends up giving me 11. And the very last one here, I have y is equal to 3 times 4 plus 2. So all I'm doing is replacing the x value with the x coordinates that I've decided to use. And again, I just picked easy numbers there. So 3 times 4 is 12. And then 12 plus 2 is 14. All right. So You might also notice yourself that this kind of resembles a little bit the linear patterns that we talked about on the very first day when we kind of were reviewing a little bit of math from grade 8. It's looking very similar to that, right? I'm actually going to just write these out. So 2, 5, 8, 11, and 14. So some of you might have already been able to notice this yourself, even before doing a table of values and completing it and subbing it in. You might have already noticed that there's a bit of a pattern. We're simply just adding 3 each time, right? I think most of you can kind of start to see that little bit of a pattern, which resembles the linear relations that we talked about on the first day. There are the linear patterns. We're specifically talking about linear patterns there. So it's really similar idea here. So what we're going to do now is, now that we have our table values completed, I'm just going to simply pair up the x and the y coordinates before I plot them out. It's just a nice, easy way to do this all together. So I'm going to have -2 and -4. And I have -1 and -1, 0 and 2, 1 and 5, 2 and 8. So that's an 8 right there. 3 and 11. And finally 4 and 14. So what I'm going to do next is I'm going to scroll down a little bit and I'm going to make my graph now. So to make my, before I even start the graph, get a ruler, make sure you have a ruler. I don't obviously have a ruler at this moment, but I am going to do my best to draw a straight line here. So I'm going to have, and actually got a little bit cut off there. So it's going to look something like this. Oops, that's not a straight line. Just pretend, use your eyes there. And then we have 4 and 14. Yeah, this is not going to be perfectly straight, but I'm going to try my best. This is a test of how steady your hand is. Mine is not for some reason. All right, but I tried my best there. Obviously, if you have a ruler, even better. I'm just doing a freehand here, so it's not going to be perfect. So what I'm going to do next is I am simply going to label my graph. So you should always label it. Make sure that it's just even for your own sake, right? So you know where the points go. It's very easy to make a mistake here. So we have 0, and then maybe I'm going to go by 2s, 4, 6. I'll kind of stop there, and then I'll go on this side. So I have -2, -4, -6. And then over here, I'm going to have 2, 4, 6, 8, 10. Apologize for doing this. I know it's kind of tedious to do this, but I want to do at least one example where we graph by hand. And again, the usefulness of technology, right? It can speed up a little bit of the work here. All right, so we end up getting 2, 4, 6, 8, 10, 12, 14. And again, if you have decimals, you can absolutely use this. I just want to show you just how to do this by hand, because there are examples where you will obviously have to graph by hand and you won't always have decimals there. So -4, -6, -8, and -10. Okay, perfect. So what I'm going to do now is I'm going to plot these points. And I have my points up right up here. I know it's -2 and 4 for the first one. So I'm just going to change the color so you can see it. So -2 and 4 is going to be, sorry, -2, if I'm not mistaken, it was -2 and -4. So -2 and -4 is going to be right here. And then my next one is going to be -1 and 1. So I look for -1 and 1, which is right there. And then I have my next point, which is 0 and 2. And again, my graph is a little off because I obviously did not use a ruler. 0 and 2, sorry, 0 and 2 is right there. Then I have 1 and 5. 1 and 5 is right here. And then I have 2 and 8. Right there. 3 and 11, and finally 4 and 14. Okay, so now that I have this graph here, now that I plotted the points, I can do a straight line going through these points, and it's going to be a little rough because the points themselves are a little, like my grade itself was a little off, but I'm going to do my best to do this. So, oops, I want to make sure I use the correct, a different color, not to confuse you. So let's pick this green one here. Okay, so I'm going to do my best to draw a straight line going through them. So it's going to look something like this. And not too shabby, actually. So that's what our line is going to look like. So this is what the line of y is equal to 3x plus 2 looks like altogether. And of course, I forgot something really important here. My labels, x and y. There we go. So for my x and y coordinate, I should always label that there. This is what our graph ends up looking like. So in part 3, I actually want you to compare your graph directly with decimals. So what we're going to do is we're actually going to draw out this graph exactly on decimals. So we go to decimals here, and we're just going to compare it step by step. And I can actually put this on a different window so we can kind of compare them directly. Let me just minimize this, and I'll minimize this one here, just so I can compare them directly here. Okay, so going to this one here, we are going to simply type in our equation. So we have y is equal to 3x plus 2. And again, I've mentioned this already in the last video. You normally want to get rid of the minor grid. So go to the wrench, this settings button, little wrench there. Get rid of the minor grid lines. It just makes it less confusing. And then go by ones. I would say going by ones is a lot easier. Now, obviously, I had zoomed in a little bit, so you miss some parts. If you want the graph to go out of the way, maybe you don't need it at the moment, you can just move it out of the way there. So this is what the graph is going to look like in the end, which I must say looks pretty close to this. And we can move it around so we can see more of it. Yeah, it looks pretty accurate. I would say it's pretty good. It does have a lot of attributes. That's 14, by the way. Yeah, we can see it's very similar. So it definitely looks like the correct graph there. Now, another really important little tool here for decimals, I just want to show you a couple more little tricks here. If you, for whatever reason, need to just plot specific points, so let's say in the last example, we were actually plotting out the points first, and then we joined them using a line. You can certainly use decimals for that as well. So it's not just equations. So let's say, and I believe the first one was -2 and -4. So if I want to plot -2 and -4, there it is. And I believe the next one was -1 and -1. And I can plot that there. And then I believe the next one was 0 and 2. And then we had 1 and 5 and so on. So if you actually want to plot, let's say you want to plot this out and you didn't have grid paper, you want to use this, you can certainly use these points to kind of help you visualize what the line looks like. But of course, if you have the equation, that makes it a lot easier too. Another little trick here, and this is also going to be really nice when we get to correlation, you can actually do a table of values altogether. So instead of doing point by point, you can actually add on a table of values, and you click on this little table there, and then you can start putting in your points. So again, another really great tool that's on decimals, which is awesome. So going back to this last example, we can obviously saw that the line was the same. So we had y is equal to 3x plus 2. It is the exact same line that we had. Now I want to compare them directly, and for this next example, I can either, for question 4 and question 5, I can either pick points from the graph here that I did using decimals, or I'll pick the graph here. Now, even before we start analyzing this, I think some of you might already start to see a bit of a pattern here. In our last lesson, we actually talked about the first difference, which is the difference between the y values, right? So we kind of start to notice that the first difference is like the step pattern, and we can see here that the step pattern is 3, right? We're increasing by 3 each time. So this 3 that we're increasing by each time is also known as our first difference. And we learned in the last lesson how to calculate the first difference. All you do is you take the y coordinate that you have minus the y coordinate before it, and we end up getting +3 the whole way through. And then we also notice on this graph that if that generally speaking, what's happening is we seem to be going up by 1 every single time the x coordinate goes up by 1. So very interesting. Sorry, we're going up by 3. Sorry, that's what I meant to say. We're going up by 3 every single time that the x coordinate goes up by 1. So very interesting that they're in both the graph and the table values, we seem to be increasing by 3. That seems to be a general pattern here. So does this what does this really tell us, right? What's the connection between slope, y-intercept, and of course the equation itself? Some of you might already start to notice something special about this equation. This equation itself, y is equal to 3x minus 2, sorry, y is equal to 3x plus 2. There's a 3 attached to that equation. So does that 3 actually indicate anything to you? So some of you might start to be taking a little bit of a guess as to what's going to happen here. So what I want you to do for part 4 is I want you to pick 2 points on the graph, and then I'm simply going to ask you to write down their coordinates. So I'm going to make my life a little bit easier. I can pick points that are near each other, maybe not directly near each other, just so we can see a bit of a difference. So why don't we pick, let's pick this point over here. And I don't think it's actually highlighting. Let me see. Nope, it's not going to highlight. Okay, sorry, I'm just gonna get a different color here. Okay, so why don't we pick this point over here, which is 3 and 11. So I'm gonna pick 3 and 11, and just to change it up a little bit, why don't I pick this one right here, which is 1 and 5. And again, you want to pick 2 points that are easy to read. I ended up picking these ones because these are points that actually were coming from the table of values. So I could have actually picked points directly from the table of values, but on this question, I asked you to just take it from the graph, but really they come from the table of values anyways, right? So I decided to pick 1 and 5 and 3 and 11. You could have picked points that were directly near each other, but I mean, directly next to each other, but that's fine. I'll actually show you it doesn't really make a difference at all. It doesn't actually matter which 2 points you pick, and it will work either way. So we have 1 and 5 and 3 and 11. So I'm just going to demonstrate what happens next here. So what we're going to do is we are going to take our 2 values. Actually, I'm just going to erase this so it's a little more neat here. Sorry, I apologize for this, guys. It's just because I know I'm going to be uploading this later. So I just want to make sure that the solutions are as tidy as possible. So 1 and 5 and 3 and 11 are the 2 points I picked, and I could have picked any 2 points. So what I'm going to do now is I'm going to find out what the difference is between the y coordinates and what the difference is between the x coordinates. So the difference between the y coordinates is simply going to mean that we're going to subtract off the y coordinates themselves, right? So let's do that first. So when we subtract 11 minus 3, so that's all we're doing is find the difference between 11 and 5. So we take 11 minus 5, which ends up giving us 6. And then we're going to do the exact same thing for the difference between the x's. We're going to find out what the difference is between 1 and 3, which is the same thing as saying 3 minus 1, right? So we take 3 minus 1, and that ends up giving us 2. And again, you need to be really consistent with this. We could do the difference of the 2 points as 5 minus 11, but if we decide to go this direction, we have to be consistent and do 1 minus 3 as well. But I decided to do 11 minus 5 and then divide that by 3 minus 1. So what we're going to do next is we are going to, just made a little error there. We are simply going to find out what the slope is now that we know what the difference in the y is and what the difference in the x is. Because we actually found out that slope is the same as rise over run. And we talked about this in the last lesson that rise over run, if you look at it on a graph, the rise is really just telling you how much the y coordinate changes by, and the run is telling you how much the x coordinate changes by, which is really exactly what we're finding here. This is the change in x. So another word for difference is the change in x. And then this is the change in y in the numerator. So the change in y, if you ever hear those words, so I just want you to be kind of familiar with what they mean, right? Change in y is rise, change in x is the run. Okay, so how do we calculate the slope? We simply take the change in y divided by the change in x. So we take 6 divided by 2. And of course, I'm just going to erase this here. Oops. 6 divided by 2 ends up giving us 3. And again, we're going to notice something here. 3 was actually what we calculated to be the first difference, right? So we're kind of starting to see a bit of similarities with the first difference and the slope. And we also might notice that when we look back at our equation, our final answer when we calculated the difference in y over the difference in x was 3 here. This is also the exact same number that we see in the equation of the line. We see that 3 was our slope. So it's not a coincidence at all that we have this. So we already start to notice that really what we have is the slope is actually the value or the coefficient that is attached to the x variable, right? So that kind of makes sense because we're taking our x variable and we're multiplying by multiplying by how much it increases or decreases by. So it makes sense that it would be the coefficient of the x variable. So we start to see here that the slope is actually the coefficient of the x variable. So I'm going to write that over here. Slope is the coefficient of the x variable. And if we specifically look at our graph here, let's say that, sorry, our equation, let's say that our equation is y is equal to mx plus b, and I'll talk about what this means. The m value right here, oops, I'm just trying to get a different color here. The m value that is right here, and so the coefficient of x is going to be our slope. This actually tells us what our slope is. And this is also the exact same thing that we see for the first difference. Right? And that's our first difference for when the x coordinates are all increasing by 1. For x variables increasing by 1. And we kind of talked about this. Sometimes they don't increase by 1. That's a little bit different, but if they're all increasing by 1, then we see that the slope and the first difference are actually the same. And really, if we just look at the equation that was given to us, that equation that was given to us from the very beginning actually tells us what the slope and the first difference and the rate of change were all together. So you're probably looking at this and saying, well, so I could have really answered what the slope was without doing all this work? Absolutely. You would just look at the coefficient of x, and that already tells you what the slope is. So quite a powerful idea there. So in our second part here, it says to look at the graph of question 2 or 3, and it says where does the graph of the line cross the y-axis? So this is actually called the x-intercept. And what do you notice about the x-intercept compared to the equation of the line? Well, let's look over here. So our equation, our y-intercept is this point right here. And actually, let me just get it. I'm kind of running out of colors here. Let's just use this brown one here. And we're going to identify our y-intercept. Our y-intercept is at 0 and 2. So I'm going to write this over here. Y-intercept. This is our y-intercept right there. So what do we notice looking at the y-intercept here and then looking at our equation over here? Well, we might notice that the equation is 3x plus 2. So it would actually make sense that this constant that's by itself will actually tell us what the y-intercept is. So the number that is totally by itself in the equation is telling us what the y-intercept is. And that's also very powerful as well, because if you know that there is a number attached after the variable x, so if we have a constant all by itself in the equation, then we know it's going to be a partial relation because the y-intercept is not equal to 0. And if you don't see anything, that means that the y-intercept is 0, which means it is a direct variation, right? And we talked about that in the last lesson. So going back to this, we actually notice that the y-intercept is the constant of the equation. So if I write down the equation once again, so I have y is equal to mx plus b. Now I'm going to notice that, oops, I'm just going to change the color here. I'm going to notice that the b value right here is my y-intercept. So the one that is totally by itself, the number totally by itself, the constant in the equation is going to be the y-intercept. So really, once again, I could just look at an equation given to me and I could easily tell you what the y-intercept is just by looking at the equation. Simply look for the number that's by itself in the equation there. And if you don't see a number, then it's automatically 0. And if the y-intercept is 0, we know that it is a direct variation. So you already know a lot of information there. So in summary, we see that for an equation, and sorry, I should be clear, for a linear equation, so for a linear equation, of the form y is equal to mx plus b, the coefficient, so I'm just kind of piecing this all together, the coefficient of x, and I'm going to erase that because this looks a little bit messy. The coefficient of x is the slope. Oops, let me erase this. And of course, we'll talk about this in a lot more detail in lesson 4 as well. But I just wanted to introduce this idea because it does come up already. So it's the m value there. And for a linear relation, same idea. So for a linear equation of the form, and it's the exact same idea, y is equal to mx plus b, the y-intercept is the constant. So it's going to be our constant b right there, the one that's by itself there. Now, what does this actually mean? And you're going to see a couple word problems. So for the homework, you're going to notice you're going to have a couple of different word problems. And this is where it starts getting a little bit difficult because you're probably thinking, well, what does this have to do with linear relations in the first place? Well, what we're really doing is we're trying to see the connection between a graph and what we actually see in real life. So slope is basically telling you how much you're increasing or you're decreasing by. So in real life, when would you actually be looking at this? Well, if we know how much, for example, the price, and this is one of the homework questions. So if you look on page 157, number 8, there's a graph that tells you the cost of renting a hall. And we can see here that the cost of renting a hall is based on number of people. So the more people that are in the hall, the more you pay. That makes sense, right? Because you pay per plate. So the more people that are there, the more you're going to pay for the whole hall. So in this case, and slope would be how much we're paying per person. So it's how much we're increasing, how much our price is going to go up by for every single person that attends. Whereas the y-intercept, what the y-intercept tells us is where does the price begin in the first place? So the y-intercept, we can always think of it as our starting point. If that's the best way to explain it. Y-intercept is basically like your starting point. Where does your line begin from? So in a real life problem, it would be like your initial value, your initial price. Whereas slope would be how much you are increasing by every single time. So that would be, how much you pay per person, how much do you earn per hour, how much do you earn per year, how much does it increase by, right? So you're looking for all those keywords there when you're trying to decipher whether we're discussing slope or y-intercept. And again, we'll talk about the word problems a little bit later on. But for now, you are going to start to encounter a couple word problems here or there. So I just want you to kind of be aware of that terminology. And that's it for now. So again, the homework, you have some textbook work, and then you also have a handout as well. And of course, your homework is also to complete this activity. But if you've been following along with the video, then you definitely went through it. So that's awesome. All right. Good luck.